Alternative energies have always interested me, so I decided to construct a Stirling engine for under $20. It's completely external, which means that there's no explosions going on inside of it. All that's going on is just air is being heated, which pushes the piston up. I thought it was innovative because we can use solar power these days. We can make a machine that's much more precise than this. This is very crude, but we can make a machine that's a lot more precise, and we can use mirrors to concentrate the sun's energy to the bottom of this can and use heat sinks to pull the heat away. In this case, I use a gas burner for the heat source, and I use ice cubes to pull the heat away. So without further ado, let me show you my Stirling engine. This was a pretty straightforward project to construct, except for the crankshaft, which was bent with needle nose pliers. Everything was constructed out of tin cans. I have a tin can here, a tin can in the bottom, and a tin can within it to displace the air, to facilitate the airflow up and down. I built a piston out of pipe fittings and a pipe, and I used J-B Weld to fill it in. This collar is not a piston, but rather it's just meant to keep the water out. So here's my Stirling engine. It works by air expanding when it's heated. It pushes this piston up, and then the ice cools it, which makes the air compress more, which makes it easier for the piston to compress it. The displacer, which is right here, all that does is just move air up and down and up and down. It does not actually do real work on the flywheel. It's my Stirling engine. I think it's important to see a better diagram. You can't really see what's happening with the displacer. So here's a better diagram. Notice the heat is pushing the piston up, then it's cooled, and the displacer only moves the airflow back and forth. This is a paint can lid that I used for the flywheel, by the way. Thank you.